Welcome back. In this second part of the module, we are going to take a deep dive into core spatial operations on vector data. These include joins, buffering, merging, and distance calculations. Each of these is a fundamental building block of spatial reasoning, and each one has direct applications in the energy sector. We will show how to perform this operation in both QGIS and GeoPandas, and we will use real-world examples such as associating PV plant with substations, defining safety zone around power lines, or measuring distance from infrastructure. Let's start with joins. A join is a way to enrich a layer with data coming from another source. There are two main types, attribute joins and spatial joins. Imagine you have a shapefile of wind turbines and a separate table that contains power output measurements per turbine ID. With an attribute join, we can match those two based on a common field, for example, the turbine ID. Now, spatial joins go one step further. Let's say you have solar plants and a shapefile of substations. You want to assign each plant to the nearest substation. Here we join based on spatial proximity. Spatial joins are powerful. They let us answer questions like which plant is in which municipality or what is the closest road to this wind farm. Now, let's talk about buffers. A buffer is a zone created around a feature, like a 500-meter area around a power line. This is useful in energy planning to define safety zone, visual corridors, or technical setback distances. In QGIS, you can easily do this by selecting the layer and going to Vector, Geoprocessing Tool, Buffer. Set your distance, choose Dissolve options, and click Run. In GeoPandas, creating a buffer around your feature is really straightforward. It only takes a single line of code, using the buffer function. But there is something important to watch out for. Your coordinate reference system must use meters, not degrees. If your data is still in geographic coordinates, like latitude and longitude, you will need to reproject it first into a projected system. Once that is done, you can safely apply the buffer with the distance you want. Real-world use case: define no building zones around high voltage lines or exclusion zones around protected habitats. The third operation we will look at is merging, or more precisely, dissolving features. This is when you combine several geometries into a larger one. In QGIS, this is done using Vector, Geoprocessing, Dissolve, and choosing the attribute you want to merge by, for example, country, if you are merging all provinces into a country. In GeoPandas, use the dissolve function, simple and elegant. Why is this useful? Suppose you are calculating the total area available for solar deployment in a country. First, you dissolve the regions, then you clip and measure. Last but not least, distance calculations. This is fundamental in spatial energy analysis. You often want to know how far a proposed site is from existing infrastructure. In QGIS, you can use the Distance to Nearest Hub tool in the Processing toolbox. Select your site layer and your target layer, and QGIS will compute the minimum distance for each feature. In GeoPandas, you can compute the distance to another layer using the distance function, which is efficient when checking distance to multiple lines. For example, you might filter all PV sites that are within 3 kilometers of a medium voltage line. This can help in prioritizing grid-accessible locations. So, let's recap what we have done in this session. We explored joins to enrich or spatially associate data. buffers to define zones of influence, merging to simplify and aggregate geometries, and distance calculations to quantify spatial relationships. These 4 operations are used in nearly every geospatial energy analysis. Whether you are working with hydrogen pipelines, wind turbine siting, or off-grid electrifications, mastering these tools will empower your decisions. In the next video, we will look at how to build spatial grids for systematic energy planning, a powerful technique for mapping infrastructure needs and development potential. See you there!